We are starting our first session today. So the first session starts with a topic of an open source software by Ram Iyengar, who is a chief evangelist at Cloud Foundry Foundation. His talk on how and why does the work of open source impact you. He will focus on the best practices prescribed by the OpenSSF Foundation and securing our open source ecosystem. So yes, the stage is yours.
Thanks. Hello, everyone. Good morning. I hope you had your caffeine fix and got some good networking done. The last time I heard a bell and somebody saying "chalo, chalo, chalo, chalo" was years ago. Back in college, I was probably 19, but it's nice to get that feeling again. So anyhow, welcome to Mumbai for those of you who are not from around here, and for those of you who are, I think it's a great pleasure to be talking Kubernetes, talking open source, talking CNCF in a home setting where you don't have jet lag and you don't have to worry about hotel rooms and checkouts and things like that. Now, my talk today is largely going to be focused around the OpenSSF, what it is, why that's important, and other things is obviously going to be covered during the talk. But let me begin with why I set out to design and give this talk in the first place. So I'll begin with the why. How many open source consumers do we have here? Like how many of you consume open source technology? Let's start with that question. Great. Open source maintainers, anybody? Wonderful. People who are in like open source communities or manage open source communities, things like that. Beautiful. We have some folks here. So the reason I designed this talk was because open source as a whole is threatened by this notion of supply chain security. So security problems can undo a lot of the good that open source has been doing in the world. Now, the reason why a lot of us make use of open source software might really differ. Some of us might use it to save time. Some of us might use it because it's very robust for a particular use case that you're trying to solve. Some of us might use it because they saw it on Stack Overflow. I've done it in the past, so I'm sure there's others out there like me. So there's many reasons why engineers tend to follow this path into open source and start using it. And now there's a bit of a problem in the larger technology ecosystem that in some sense threatens the use of open source itself. Now, I want to focus a little bit on why this particular topic. And the reason is because recently, a lot of the notions about supply chain security have moved into a very mainstream conversation. Have anybody here heard of supply chain security, like software supply chain security? Good, we have a handful of folks. People heard of the term SBOMs, software bill of materials, nice. People hear of the term signing images. Okay, good. So I'm going to talk about these three in this talk, so please, if it's a little boring for you, bear with me. But the point I'm trying to make is these whole notions of supply chain security for software artifacts has become more mainstream in the past weeks and months and maybe a couple of years. There was an executive order that was passed by the United States government, like the present government, and they focus specifically on making SBOMs available for software that is in use, typically by the government, but otherwise also, in order for it to be more transparent in what it is that's actually running on production. The EU is coming up with a Cyber Resilience Act, or the CRA, which is again dealing with how to make more secure digital artifacts. It's not limited just in scope to software. They do tend to include a little bit of hardware in the form of like medical devices and things like that. But the point that the act is trying to make is, there's a requirement and there's a need, a real deep need in society for artifacts that can make digital applications or technology in general more secure. There's also motion passed by the ASEAN nations, ASEAN, and that is also striving for a cooperative strategy in cybersecurity and things like that. And one of the kind of attacks that they're trying to prevent are software supply chain attacks. In India, we don't have anything yet. It's not meant as I hope you're not recording this. I don't mean that as a anything disrespectful, but I think this is an opportunity for us technologists to participate and come up with policy, participate and come up with like direction, and as a community of technologists and practitioners and using open source software to come up with ways in which I think operators from this particular geography can make their open source supply chains more secure. And then I'll focus a little bit on why I am presenting this talk. Obviously, you might think, what qualifies this individual to be coming here and speaking about this? In my full-time role, I manage the community around Cloud Foundry. Have folks heard of Cloud Foundry at all? Show of hands. This is always an indication of how old you are. So the older people in the audience generally tend to recognize Cloud Foundry. But earlier this morning, I think Janaki Ram did a name drop of Cloud Foundry during his talk as well. So Cloud Foundry, for those who are not aware, is a PaaS. So it's an open source tool. It's used in several large and small and medium organizations in order to provide like a very convenient sort of Heroku style experience on any infrastructure for any language, what have you. Now, Cloud Foundry itself is composed of like many open source projects. Some of the examples are on this slide. But the idea is like a large chunk of independently developed open source projects constitute the larger Cloud Foundry project itself, and also a bunch of the other projects that the community manages. You can consume Cloud Foundry in its open source form, but there's also other service providers and other sort of companies who provide this as a service for other people to use. Now, this is just a small example of the different adopters of Cloud Foundry. And there's like big service providers that you might recognize. There's smaller service providers which you might not recognize. But then there's also like initiatives like cloud.gov in the US and cloud.gov.uk PaaS in the United Kingdom, who all consume Cloud Foundry and help different departments create digital services over and above it. So that's really the Cloud Foundry story, and I've been a part of this community for the greater part of 3 odd years now. And on a fateful December evening, when we were preparing to take time off closer to the end of the year, one of our most memorable events post-COVID has happened. So there was a vulnerability announced that we called Log4j shell. It was basically, I'm sure people all know the story here. Some of you were affected, hopefully a small segment of you were affected by it and things like that. But the point is, when the Log4j shell event happened, it did affect our community too. So there's parts of Cloud Foundry that make use of Log4j. And so we started getting reports of all of these different components becoming compromised. And this was my first-hand exposure to a software supply chain attack at this scale. Now, if you know how open source community works, it's not like we have a large engineering team on our payroll. We operate with a very small number of program managers and events folks and marketers and me and what have you. And so there's, unlike large organizations, there isn't like a big engineering team that backs the project that's on the foundation's payroll. However, there is a large engineering team that's a part of the community itself. And so we have like specific working groups dedicated to like specific areas of the project. And then everybody started to say, hey, the build packs working group reported like the Java build pack obviously was affected. There was like a the vulnerability had crept into that component. Some of the PHP folks, because they were using some Java-based dependencies, started to see this problem as well. Some of our newer projects that were making use of Log4j started to, be flagged. And what we were unable to estimate as an open source community is how far along the diameter of our project this ripple effect was happening. Now, it is safe to assume that some of our consumers also had this problem, but I'm obviously not at liberty to say, oh no, this particular user had a problem or something like that. And so it's safe to assume that like a lot of the Cloud Foundry consumers were affected because of this. And so this was my first exposure to what a vulnerability can do to an open source project. And that is why I mentioned at the start, this particular kind of problem is not just difficult for businesses that make use of software and things like that, but it's particularly harmful for any kind of open source projects that are adopted, that are made use of, and things like that. And so that's really why I'm giving this talk and where I'm coming from. And so I wanted to focus on this software supply chain. It's ridiculously hard to Google for this term because it will give you 15 links about, oh, supply chain software, #1 supply chain software, best supply chain software for India, what have you. But it's a software supply chain. And, obviously in this day and age of chat GPT and natural language processing, it should be able to detect that. But yeah, in practice, there's like a little difficulty. And so if you'll search for the software supply chain, what you will come to realize is it's just like regular supply chains that we know in terms of logistic tools and things like that. So if you wanted to make a bottle of water, you need somebody to make the bottle, you need somebody to make the cap, you need somebody to make the label and the sticker, and obviously somebody needs to supply the water. And all of these come from different suppliers. They are aggregated, and it's like a collection of composite elements that come together to make a single product. And software today is much like that. I'm sure everybody here will agree that not all the software that you push into production is necessarily written by you. If that's the case, I really want to meet you after this talk and shake hands with you. But it could be open source. There could be some proprietary components within. There could be some stuff that you're just licensing commercially and making use of. You could be integrating with other SaaS providers who you don't even know where the data is located and stored and made use of. So the point is, because it's coming from all of these different places, securing it becomes a fairly large problem. And that's really what we are setting out to understand and realize, both through the efforts of individual communities that are tackling this, and also the OpenSSF, which I'll talk about in just a minute. And what I would like to emphasize on is, this is not a situation where we just say, hey, here's a silver bullet, use it, everything's done. No, it's a combination of tools and techniques, and what I've not put on the slide there is time. So it requires enormous patience and investment from individual developers in order to be able to put out more secure, more compliant code, which is something that I shouldn't say on a stage in a room full of developers because everybody's going to hate me for it. But that is unfortunately the truth. So there's companies that are working on providing different tools. There's obviously some open source tools as well. There's many independent research activities that are advocating the use of certain techniques in order to make software more secure and just better quality in general. And obviously, the unsaid requirement of time in order for you to take all of these tools, all of these techniques, apply them, calibrate your results, recalibrate your tests, and go do it again and again until you can find an optimal level of security. So it definitely takes time, and it's a combination of different tools that you can find and different techniques that you can hone as an engineer that is actually required in order for you to make software better. let's shift gears slightly now that we've established what the entire premise is and talk about the OpenSSF. So meet Honk. Honk is the mascot. I'm proudly wearing it on my t-shirt today. So Honk is the mascot of the OpenSSF, and the OpenSSF itself is a part of the Linux Foundation. So if folks have not heard of the Linux Foundation, it's an independent non-profit that a lot of companies have come together in order to create. The LF has a lot of quote-unquote sub-foundations. So the LF, a part of the LF are many other foundations, such as the CNCF, which a lot of people might be familiar. Another example is the Cloud Foundry Foundation, who's paying for my ticket to be here. So the LF has a bunch of different independent foundations beneath it, and the OpenSSF is one of them. So under the arc of being an open source focused foundation, it's committed to bring together a lot of different organizations and people to collaborate on security focused issues very specifically, and on security focused issues for open source software specifically. So it's a very niche and focused foundation. They're really growing at the moment. Their goal is to help make better quality software, as they time and again emphasize this on their different media. Now, some of the things that they aim to simplify and make easy for folks like developers and regulators and technology auditors, in order to make sure that policies that are being created and consumed are actually good, and they aim to create that kind of transparency. Remember that supply chain we talked about, where there's like projects and consumers and maintainers and contributors, and so they want the dissemination of information among all of these participants to be simpler and more frequent and of better quality. They also want to create a space where, when there are events like Log4j, they can all come together and talk about it, and there's a safe space for discussing all of this remediation effort, what have you. So those are the goals which the OpenSSF has been formed. And one of the things that has happened is, since the time the OpenSSF came into being, they have created this system of having various swim lanes or streams in which they intend to operate. And the reason I wanted to showcase this is so that folks here can learn about the spread of the different activity and go back, start to learn about what they're actually putting out. So again, like I said, some of these are tools, some of these are techniques, and some of these are in between those two. And start to consume these in order for things to be better quality in the software that you develop, but also things to be just upskill for yourself, and not just stop there, but come back as contributors, because obviously an effort this big needs as many hands as it can get. And if you can come back and start contributing to OpenSSF initiatives in whatever format you can, I think the project would see some great success. Now, let's take a look at each of these 10 streams of investment, and I'll be as quick as I can about it. The first stream that they want to focus on is about education and certification. So they want to deliver a pretty solid foundation or a baseline for all software developers and engineers, irrespective of their current levels. And they have identified security as being a lacuna, not just in terms of like formal college or boot camp education, but also like in the workplace. Security is often an afterthought and not something that people tend to focus on since the start. It still feels like the early days of DevOps, where they've the security seems to be someone else's problem and not the application developers. So they intend to change that by educating more people and certifying more people on security. The second stream of investment that they're wanting to focus on is a dashboard where they can make available information publicly about some of the biggest vulnerabilities that are in the technology realm at a given point of time. There's a project called Cosign. Are people aware of that? Show of hands. Cosign. Yeah, so Sigstore, Cosign. So Sigstore is owned by the OpenSSF, and so the developers are distributed across different security-focused companies, but the project itself is an OpenSSF project, and the OpenSSF team wants to push more signatures available in a more automated fashion inside build infrastructure, inside deployment infrastructure. They've covered the whole cycle of having certificate providers, of having signing infrastructure, of having a policy control that can verify that things are actually signed before deployment and things like that. And so if you've not considered adopting digital signatures for your container-based deployment workflows right now, I would highly recommend it. And that's one of the areas where the OpenSSF is investing money as well. Likewise, there's many parts of typically open source software that's written out there without an eye for memory safety. Now, this is because of two reasons. A, memory safety wasn't a very convenient thing to do 5 years, 6 years, 7 years ago. And also the more modern languages come with built-in support for better memory safety. And so it's been slightly easier for them to focus on this and do better memory safety for applications. They also intend to create an incident response team. So not a lot of open source projects generally can afford their own teams for security and things like that. And so if the OpenSSF is able to stand up a team that can contribute to this, I think it would go a long way. They also want to speed up the discovery of vulnerabilities by static code analysis and a bunch of other things. And the follow-up to that is they want to create systems for reviewing other open source code. So if you like doing code reviews and pointing out security issues in other people's code, then this might be good area to start contributing. And I think one of the more valuable initiatives that they're putting their money behind is this notion of creating a shared data set across the industry of common vulnerabilities, stuff that's affecting a lot of people and things like that. Now, one of my favorite areas of research has been SBOMs, and the OpenSSF has the backing of an SBOM standard. SPDX, I think, is their preferred SBOM format. There's also other formats that you could use. We'll try and look at a demo of this, but the OpenSSF intends to invest a lot of money in not just tools that can help generate SBOMs or create better formats and things like that, but also the ability to consume these SBOMs once they're generated. A lot of people that I'm speaking to are all aware of what SBOMs are, and they know how to generate them, what have you, but I don't see a lot of them consuming them and using them as policies in order to deploy the more secure and compliant images. And finally, the last project that they have is about packaging and distribution, where they want to create a better or an enhanced version of builds and package managers and distribution mechanisms for not just security tools, but software in general. So there's definitely some gaps that they've identified in these areas, and they intend to sort of work through that along with the community. So I know this can be a little hard to remember. This is on the OpenSSF website for those who are interested. Just search for OpenSSF streams of investment or something like that, and you should be able to find it. I thought I'll spend a few minutes going through a quick demo of some of the things that we've spoken about. What's a developer conference without some terminal love, right? So what I'm going to start off with today is I'll kick off a build process. And depending on how good the internet is, this might or might not work. So please bear with me. So I use cloud native build packs in order to build my containers. For those who are not aware of what cloud native build packs are, they are a mechanism. Oh, sorry. Show of hands. Folks aware of cloud native build packs? Yes, few. Good. So this will be interesting. So there's a CNCF projects known as buildpacks.io or cloud native build packs. What they are is they borrow from the early days of Heroku and Cloud Foundry, the notion of build packs, which are like a collection of scripts that basically download the whole internet. But apart from that, they take your source code and output a container image, and that container image is OCI compatible, what have you. But the goal is they will take this. Wait, I'm going to stop this. They tend to create images that are basically not. Pack is the CLI, yes. So pack is the CLI, and then it comes with like a bunch of builders. So builders are like base images that allow you to build the image itself. Now, what I also wanted to demonstrate is this happens without actually going into, let's see. Yeah. So if folks can see the terminal well, there's no Docker file or a manifest file or any meta file that I'm going to supply to this. And I'm going to make use of a smaller builder here. If I can find my cursor. So pack comes with like a tiny builder. So I'm going to make use of this because bandwidth is pretty low here. So I'm going to do a pack build. What am I doing? I'm going to call that image this, and I'm going to make use of like a tinier builder. So pack will create a container image without something like a Docker file. So that's one of their big wins. So you don't have to worry about having different kinds of Docker files for different environments and things like that. And the reason I wanted to mention that is there's also an OpenSSF project known as Salsa, which is like a Google contributed project, SLSA. Security levels for software artifacts, if I remember correctly. And so are folks familiar with that? I see a few nodding heads. Show of hands, anybody heard of Salsa? Yeah. So one of the things that Salsa advocates for is a parameterless hermetic build process. And what all of that mumbo jumbo means is you basically have a build process for which you don't have to necessarily every time supply a new parameter. So like if you have a Docker file based build process, for example, every time you're building for like different pieces of infrastructure, you have to do it slightly differently. And so that is not a recommended way of building containers according to Salsa. And so what Salsa wants instead is for you to have a single build command. For example, pack build container image, and it should just work. I just have a couple of minutes left. I'll let this run, and we'll pull up a different terminal to showcase some of the other things that I had in mind. Yes. Yep. Yes. True. True. That's a slightly larger question that I have to answer, but which maybe we can take offline. The long story short is there's internally the kind of scripts and other things that Kaneko uses and what it outputs is slightly different from what Pack does. That's really it. In terms of the interface for the developer itself, they're basically the same. So I'm going to showcase some of the stuff that I already did as a backup. So let's see. Jeez. Stop going to KCDs. There are. Okay, we can still do that. So let me do that. So this is a set of S-bombs that I generated for a similar talk that I gave, and I'll just quickly open that in. Whoa. Never leave computers open when you have kids around. No. Let's see. Yeah, that's better. So, yeah, so yes, so finally, so that's an example of an S-bomb. So what I wanted to demonstrate with this is S-bombs are automatically generated when you make use of a tool like pack. And this basically tells me information about every single sort of Go dependency that's in the container image that I have. Typically, folks don't know what's inside a container image, and making use of S-bombs, helps with that. There's obviously a few other things that I wanted to showcase as well, but for paucity of time, we'll skip those. I wanted to show some cosine and other things. If folks are interested, we can do something in the hallway during the next break or what have you. But so tools like pack can be consumed by build infrastructure such as Kpack and other things in order to build better SLSA levels. Tools like cosine allow you to sign your builds and output them and make use of them. S-bombs are a great way to create more transparency in your container images, and together these can help provide better security for your container-based build and deployment process, all of which are tied together by the work at the OpenSSF. And like I mentioned, check out all of the different work they're doing. Try to participate as contributors and maintainers in whatever capacity you can. And that's my talk for today. Thank you very much for patiently listening to me. And a big thanks to the organizers for having me as well. Cheers.
So it was very insightful talk by Ram regarding the maintenance of open source software. I guess the open source repository maintainer will find it very useful and will try to take some learnings from it.